Okay, good evening, ladies and gentlemen. This is Mr. Picard again, and we're going to work on relations, functions, and linear equations today, sections 2.1 and 2.2. To start out with, we got a little table over here talking about the average lifetime in years of animals versus their maximum lifetime in years as an animal. And when we compare to values like this, we call it a relation. That's what a relation is when you compare two values. So we're comparing average years to maximum lifetime. And one of the things we're going to do with these values is write them as ordered pairs. That's how you usually see them when you're comparing data. And the x value is going to be the average lifetime, and the y value is going to be the maximum lifetime. So I guess my first ordered pair would be something like 12, 28. Average lifetime of a cat. Longest maximum lifetime of a cat is about 28 years. Here's all the data points for this particular table over here. And we're going to talk about what a domain is, a range is, and a function is using this data. Well, first of all, domain. Domain is the set of all coordinates, set of all first coordinates, basically your x coordinates. So I could list the set of the domain here by doing this, using set notation, taking 12, 15, 8, 12, and 20. 12, 15, 8. You don't have to repeat the 12 again once it's in there. It's part of it. And 20. And that would be the domain. It's as simple as that. The range is just the opposite. Set of all second coordinates, or the y coordinates. So putting once again in set notation, using the set coordinates, the braces, it'd be 28, what do we got there, 30, 20, 20 again, I don't have to repeat it again, and then 50. And this is a relation because it is a set of ordered pairs. There's actually 5 ordered pairs here. My question is this relation a function? Now, a function is a special relation in which each element in the domain pairs with exactly one element in the range. What I mean by that is this: the x value doesn't repeat it. 12, well, let's look at this mapping here. Here we're saying 12 maps onto 28, just like it does here. 12 maps onto 28. The 12 matches onto the 28. 12 is in the domain, and the 28 is in the range. 15 maps onto 30. You can see it right here. 15 maps onto 30. And 8 maps onto 20. Now we are missing a couple here. They didn't put 12 and 20 in there. That would be another little arrow like this, 12 and 20. And as soon as you do that, 12 going on to 28 and 12 going on to 20, you can see that 12 repeats itself in the domain. This is not a function. Also, we have 20 and 50. I should probably put those in there. And 20 maps on to 50. Now, if I didn't have this one right here, the 12 and the 20, this would be a function because it would have a one-to-one matching of domain values to range values. But being there are 2 12s in the domain, it's not a function. A lot of people get confused with the range. Could I have 2 20s in the range? Yes, and it would still be a function. But because there's 2 12s in the domain, not a function. Another way to look at graphs in ordered pairs is actual graphs like this, and use what's called the vertical line test. If no vertical line intersects a graph in more than one point, then the graph represents a function. So if we took a line, let me see if I can get a line here. Sure, there's a vertical line. If you can run this vertical line through there and only hit one point, that means the x matches onto the one range value. That's a one-to-one function, okay? But if you go over here, the graph, this line is hitting more than one point at a time. For example, it's hitting a point here and here. Let's move it over so it's like right at the 2. So I have a coordinate of like 2, well, it looks like it's 2.25, and this one is 2 and negative 2.25. So the x values repeat themselves. It is not a function. It doesn't pass the vertical line test because it goes through 2 points in the same function through this vertical line. So that's the vertical line test. Using your graphing calculator. You can use your graphing calculator to check and see if functions, if relations are a function, like is y equals 3x squared minus 5 a function? Yes or no? Just by looking at it, you probably don't know for sure. But what you can do is put it in the graphing calculator. So that's what we're going to do here. In order to do that, you got to get on the graph. All I did was hit the graph button. You can see it right here where it says graph highlight, and I just selected it. Sometimes you have to hit the tab button to get this f1 of x down here, this little bar here where you can type in your equations, but I'm already down there. So I'm going to type in 3x squared. Let me see what it was. 3x squared minus 5. Minus 5. And then just hit enter. And you can see here that if you took a vertical line through it, it wouldn't cross the graph in more than one spot. So this would be a function. Now if this graph was spin to the left or the right, then it wouldn't be a function. But in this case, it passes the vertical line test. So you guys can type in that other one. This one right here. Type in both of them. Y equals the square root of 1 minus x squared, and y equals negative the square root of 1 minus x squared. At the same time, type them into one and then type them into the other one. For the little box where you type in your equations, you'll see it kind of makes a circle, and you can see if that's a function or not. Okay, what do we got here? Okay, so state the domain and range of each relation. State whether the relation is a function or not. So looking at my x values, -4, -3, 0, and 1. -4, -3, 0, and 1. Now I can tell you if this is a function right now. Do any of the x values repeat themselves? No, it would pass the vertical line test. This is a function. The range, doesn't matter if that repeats or not. 0, 1, -2, and 2. It doesn't repeat. But once again, it doesn't matter. If it does repeat, it could still be a function. This particular one, it's a graph. You can still list the domain and range. I'll do the domain first here, x values. I got -4, -1, and 0. And then we also have here 2 and 3. Now, none of my x values repeat. This is a function. The y values do repeat though. Starting with the smallest, I got -4, -2, and -3. And then I have 2 at 3. So I'm just going to put 1, 3 in there. You don't need to put both of them in there. And we're done. It's still a function. I know that the y values or the range values repeat, but that doesn't matter. It's only not a function if the y values repeat. So we get into what's called function notation here. Function notation, if a relation is a function, you can replace the y with f of x. What they mean by that is this. Y equals 3x plus 1. That's a relation. Because you could plug in values for x and get values for y. You'd create a bunch of ordered pairs. It is a function. You can plug it into your graphing calculator to make sure, but it's just going to be a line, which is a function. And what they do is they say you can replace y with f of x. So I could rewrite this, replacing the y with f of x equals 3x plus 1. You don't do anything differently with it. It's just a different way of naming it. F is just the title of your function, and x is just the input variable. When we talk about independent and dependent variables, x is usually the variable representing the domain. That is your independent variable. And your dependent variable, and this is just the y, representing the range. So your domain is the independent variable. Your range is a dependent variable when we're working with functions. And we're going to evaluate some functions here. It says given this function, f of x equals x squared plus 2, find f of negative 3. Well, the title of the function is f, so we're going to plug it into this function right here, and we're going to put negative 3 in for x. So f of negative 3, plugging it in for x right there, and then plugging it in for x in the expression part of your function. It'd be negative 3 squared plus 2. And then you just evaluate. Negative 3 squared is 9 plus 2, and that is 11. So you could say f of negative 3 equals 11. If you want to write it as an ordered pair, this is what it would be. Well, x and f of x. Now remember, f of x is the same thing as y. We plugged in negative 3 for x, so the negative 3 goes right here. And the 11 is what you get for f of x or y. Negative 3, 1, 11. Negative 3 would be your domain, and 11 would be your y. Let's try a few more of these. Okay, given g of x, find the following. Well, first we want to find g of 2. Okay, g of 2 is going to equal, plugging it in right here for x and here for x in the expression part, 3 times 2 minus 2 squared. So it's a 6 minus 4, and that's just going to give me 2. Pretty easy. You guys have done this before, I'm sure. Okay, this one, a little bit more work involved. First you're going to find g of 3, then you're going to find g of negative 1, and then multiply the two together. So g of 3, first of all, is 3 times 3 minus 3 squared. Times this g of negative 1, I'll find that also. 3 times negative 1 minus negative 1 squared. So we get 9. 3 times 3 is 9, and minus 3 squared is also 9. I get 0. So g of 3 equals 0. Well, my final answer is going to be 0 because 0 times anything is 0, but we'll finish this up. Negative 3 minus negative 1 squared. Negative times negative is a positive, so that's positive 1. That's going to give me negative 2. So g of negative 1 equals negative 2. So if I looked at like this as g of 3 times g of negative 1, this would be 0 times negative 2. 0 would be my final answer. Let's go back up here and get this last one. Okay, now we're actually plugging in an expression, not just a number, but an expression. You don't do it any differently. We're going to plug 3 of x in for x. So we're going to find g of 3 of x. I'm going to plug this whole thing in for x right here and right here. So it's 3 times 3 of x minus 3 of x squared. You do exponents first, but it doesn't matter because you got to subtract here in the middle anyway. 3 times 3 of x is 9x minus, basically 3x squared is 3x times 3x, which gives me 9x squared. They're not like terms, so this is your answer. G of 3x equals 9x minus 9x squared. It is an expression. So we are done there. And I think what we'll do is we'll finish the rest up tomorrow in class. So have a good evening. See you tomorrow. Peace out.